Welcome to our MathLinks webinar, Dig into Proportional Relationships, a Bagel Problem. I'm Shelley Kriegler, one of the authors of MathLinks, and our presenter is another MathLinks author, Mark Goldstein. We hope you enjoy the session. Take it away, Mark.
Thanks, Shelley. Let's get started. In this session, we're going to use a familiar context and multiple representations to explore slope and intercept, unit rates, and proportional relationships. Welcome to our bagel shop, Schmear and Things, where you can buy 4 bagels for $3. Assuming you can buy just one, what would that cost? We can call this a unit rate or unit price. Here's where we can start to dig deeper. Let's look closer at the Shear data and draw a double number line. Here are the two number lines. Notice though that they're actually raised. We're going to start at 0 because our variables can't be negative. We make equally spaced tick marks. We label the number lines with variables from the table. We write our given rate, and then we can begin to place values according to the scale we decided on. Here's some reasoning we can use to place more values. Double. Double again. See how we're careful with the scale here, unlike in a table. Use halving to find more ratio pairs. 12 bagels is halfway between 8 and 16. 2 bagels is halfway between 0 and 4. And 1 bagel for 75 cents represents the unit rate or unit price. Double number lines can be used to connect to a graph in 2 dimensions. Let's change the cost number line so that it's the vertical axis. And then let's reposition the bagels number line so that it's the horizontal axis. And here's our graph showing the cost versus number of bagels. What began as ratios of values in a table or on a double number line are now ordered pairs on the coordinate plane. Now let's make some more important connections. Notice we've changed the vertical axis scale from dollars to cents. These arrows represent a visual for the increase in cost per increase in number of bagels. And this is the familiar rise over run ratio we first learned when we study slope of a line. Here we can calculate 75 cents for every 1 bagel, so that the slope of the line is in fact the unit rate we saw before. And to hit the point home even more, notice the point where x equals 1 has a y coordinate that is the unit rate. Furthermore, in this context, where we have 0 bagels for 0 cents, we see this is represented as the y-intercept. Knowing the slope and intercept of the line gives us our equation in y equals mx plus b form. Remember that the slope of the line is the unit rate. Finally, let's shake things up in Bagel Land. Here's the original table for Schmear. Notice that if we double the number of bagels, the cost doubles. Halve the number of bagels, the cost halves. This represents a proportional relationship. And the associated equation is in the form y equals mx. What if we wanted our bagels delivered? Here's a new table adding in $5 for delivery. Notice that every entry in the cost column is simply $5 more. If you double the number of bagels, does the cost double? Nope. If you have the number of bagels, is the cost cut in half? No again. This does not represent a proportional relationship. You'll see that the constant added at the end of the equation accounts for the extra $5, and this equation is in the form y equals mx plus b. Let's analyze the same data graphically. First, Schmear with in-store pickup. Then the more expensive Schmear with a delivery charge. Notice each point on the graph is exactly 5 units above the points on the other graph. Here are the associated equations. Note that the proportional relationship is represented by the line that goes through the origin. In this session, we looked at a variety of representations like tables, double number lines, graphs, and equations in a Best Buy context. We also explored how slope, unit rates, and the concept of a proportional relationship are related. We hope you enjoyed it.
Thank you, Mark. That was terrific. What you just saw is one of 2 sessions that use the cost of bagels as the context to explore representations, proportional reasoning, and linear functions. Please check out the other one when you get a chance. The Center for Mathematics and Teaching is the home for all MathLinks programs. These include comprehensive curriculum for grades 6 through 8, customized intervention programs, and professional development. For more information about our programs, please visit our website at www.mathandteaching.org. We hope you found this session to be valuable. Please feel free to contact us anytime. See you next time.